Hello students, week 14 physics for grade 11, chapter 34, lesson 7, direct current and alternating current. Textbook page from 688 to 690. At the end of the lesson, you will be able to distinguish between direct current and alternating current. Okay, the meaning of DC is direct current, which refers to a flow of charge that always flows in one direction. A battery produces direct current in a circuit because the terminals of the battery always have the same sign of charge. So there is always a flow in one direction. Electrons always move through the circuit from the negative terminal toward the positive terminal. So this is one direction. Even if the current moves in unsteady pulses, so long as it moves in one direction, only it is direct current. You can see the graph. This is a graph of actually direct current, DC current battery, you can say. So the current flow is only in one direction. What is alternating current? As the name implies, it is electric current that repeatedly reverses direction. Electrons in the circuit move first in one direction and then in the opposite direction. They alternate back and forth about relatively fixed positions. So this is accomplished by alternating the polarity of voltage at the generator or other voltage source. You can see the graph here. This is the graph of alternating current. So you can see there is repeatedly change. Okay, you can say directions are continuously changed up and down. Voltage standards. Voltage of alternating current in North America is normally 120 volts. So for alternating current in North America, the voltage is normally 120 volts. Listen, for direct current, if you are using a battery or even DC generator, there is a fixed voltage, but for alternating currents that can be different according to the generator used in power stations. In the early days of electricity, higher voltages burned out the filaments of electric light bulbs. So in the early days, there were higher voltages used, but definitely there were problems of burning the filaments of electric light bulbs. So they moved to lower voltages. Power plants in the United States prior to 1900s, actually they adopted 110 volts, or you can say 115 to 120 volts as standard. By the time electricity became popular in Europe, light bulbs were available that would not burn out so fast at higher voltages. So at present actually light bulbs are available that can even work in higher voltages. Power transmission is more efficient at higher voltages. So Europe adopted 220 volts as their standard. So each countries can actually have their own standard in the voltages. The United States stayed with 110 volts. Now I can say officially 120 volts because of the installed base of 110 volt equipment. They have already installed base of 110 volt equipment, so they are still using 110 or 120 volts. 3-wire service. Although lamps in American home operate on 110 to 120 volts, electric stoves and other appliances operate on 220 to 240 volts. So they need some high voltages for some devices. So what do? Most electric service in the United States is 3-wire. So they have a 3-wire service. 1 wire at 120 volts positive, 1 wire at 0 volts neutral wire, 1 wire at a negative 120 volts. So these are the 3 wires in 3-wire service. In alternating current, the positive and negative negative alternates at 60 hertz. A wire that is positive at one instant is negative of a second later. So most home appliances are connected between the neutral wire and either of the other 2 wires producing 120 volts. So for home appliances, 2 wires, one neutral wire and another one is connected with 120 volts. It can be a negative 120 or positive 120, it doesn't matter. When the plus 120 is connected to the minus 120, it produces a 240 volt. So there is a difference of 240, you know. So 240 volt difference is produced, and just right for electric stoves, air conditioners, and clothes dryers. So according to the home appliances, there can be difference in the voltages, and these are actually what you call it, produced by connecting the wires according to their own voltage terminal. 0, negative 120 and positive 120 are there. When 0 is connected with one of these 120 volts, 120 is the difference, and that will be enough for most of the home appliances. But for some appliances like stoves, air conditioners, and clothes dryers, they need 240 volt difference. So what's happening, minus 120 is connected to plus 120, so the difference 240 is actually produced. The popularity of AC, means alternating current, arises from the fact that electrical energy in the form of alternating current can be transmitted great distances. Easy voltage step-ups results in lower heat losses in the wires. So the primary use of electric current, whether DC or AC, is to transfer energy from one place to another. Now there is a question, what are the two types of electric current? Try to find the answer. Thank you and see you next time.